Independent Study Project LCD Digital Clock. This software-based ISP explores variable counting and the implementation of software for hardware materials. The display component of this project is the LCD screen. Using LED-type matrices with the dimensions 5 by 8, this LCD screen can display up to 32 characters at a time. It is capable of displaying characters in the English alphabet, Japanese alphabet, special characters, and numbers. To be able to display English characters and numbers and special characters, the LCD has to be wired with data bits 4, 5, 6, and 7 to an Arduino in this method. This can be done with this PCB employed in the project. The pins are meant to fit perfectly into an Arduino Uno. The data subcircuits within the LCD are provided power and ground through the leftmost pins 1 and 2. The data bit pins from 7 to 14 provide the instructions on how to write each character. Data transfer instructions are done through pins 4, 5, and 6, RS, RW, and E. Pins 3, 15, and 16 manage the light within the LCD. The light that is observed is not the result of direct power, but the result of reflection and polarity. As a result, it requires a potentiometer to be wired to contrast to be able to be seen from different angles. A higher contrast would make it easier to be seen at an angle. A lower contrast would make it easier to be seen perpendicularly, straight at the LCD. Writing LCD instructions into the Arduino program has to begin with an inclusion of the LCD Arduino library, followed by a connection assignment of each LCD and Arduino pin. It can then be freely used to write characters based on the digital LCD pins that have been wired to the Arduino. Elsewhere, the creation of most of these characters come from variables. The variables are set to update based on the status of the other variables, with the initial setting of 12 AM. The only variable that is an exception is S for seconds, which updates every 1000 milliseconds. The other exception is if the variables are updated from the external buttons on the Arduino. These buttons are initiated and enabled for 30 seconds. If the buttons do ever end up triggering an overflow, which would cause the variables to shift from seconds to minutes, and minutes to hours, and hours to the flag, which is AM and PM, only certain overflows would happen and the others would remain stagnant. Overflows generally happen as a result of natural time process. The use of this code saves the time and space from the use of hardware materials which would otherwise complete the functions. The primary example being the real-time clock IC, but also in the way that the buttons are connected to the Arduino by implementing them as input pull-ups. This saves the hardware struggle of having to maintain a high signal and a low signal on each end of the button while not in use. Thank you for listening.